A star is reborn. Witness the celestial wonder of T Coronii Borealis upcoming nova in 2024. Every so often, the universe gifts humanity with a breathtaking spectacle, an event so rare and awe-inspiring that it stirs not only the minds of astronomers, but also the imaginations of anyone who has ever looked up at the night sky and wondered what lies beyond. One such cosmic marvel is almost upon us. Mark your calendars and prepare to gaze skyward. A nova, a dramatic stellar explosion, will soon light up the heavens in a way few alive today have ever seen. In September 2024, the long-dormant T Coronii Borealis, a white dwarf nestled within the constellation Corona Borealis, the Northern Crown, is expected to erupt in a thermonuclear blaze visible to the naked eye. This will not only be a celestial event of extraordinary power, but also a chance for all of us, from seasoned astronomers to curious stargazers, to witness the temporary birth of a new star. What is a nova really? To the casual observer, a nova may appear like a star suddenly igniting into existence, a luminous newcomer joining the night sky for a short but dazzling time. But the reality is far more dramatic and fascinating. A nova occurs when a white dwarf star, the dense remnant of a once sun-like star, accumulates hydrogen-rich material from a nearby companion, typically a red giant. Over time, this stolen matter builds up on the white dwarf surface, forming a volatile layer. When the pressure and temperature reach critical thresholds, the hydrogen undergoes a thermonuclear explosion, a process called thermonuclear runaway. The result is a sudden and massive release of energy, causing the star to brighten dramatically by a factor of up to 1,500 times or more. This temporary increase in brightness is what we call a nova, from the Latin word novus, meaning new. For days, or even weeks, the nova shines so brightly it can be seen without a telescope, even from cities with light pollution. And then, as suddenly as it appeared, it fades back into obscurity. But don't confuse a nova with a supernova. While both are brilliant stellar explosions, a nova is a surface eruption that doesn't destroy the white dwarf, allowing it to repeat the process over and over again. A supernova, on the other hand, signals the end of a star's life and can lead to the formation of neutron stars or black holes. The star of the show, T Coronii Borealis. Our upcoming nova will originate from T Coronii Borealis, affectionately called the Blaze Star, due to its occasional flare-ups. Located about 3,000 light-years from Earth, this binary star system consists of a white dwarf and a red giant dancing around one another in a gravitationally locked embrace. The red giant, in its dying days, is shedding its mass, while the white dwarf, small yet enormously dense, greedily pulls in this stellar material. This cosmic cannibalism builds up hydrogen on the white dwarf surface until, roughly every 80 years, the conditions are ripe for an explosive nova. T Coronii Borealis has only erupted twice in recorded history, once in 1866 and again in 1946. Astronomers have been watching it closely ever since, and recent years have shown the same telltale signs that preceded the past eruptions: increasing brightness, irregular flickers, and heightened emissions in radio and X-ray wavelengths. The star is literally on the brink, and all evidence points to September 2024 as the likely window for the next eruption. Where and how to see it? You won't need sophisticated instruments to witness this astronomical event. In fact, binoculars or even just your eyes will be sufficient. Here's how to find it. Look for the constellation Corona Borealis, a semicircular arc of stars located between Boötes and Hercules. If you're unfamiliar with these constellations, locate the bright star Arcturus in Boötes. To the left of Arcturus lies the arc of Corona Borealis. T Coronii Borealis is located within this arc. It's normally too faint to see without a telescope, but during a nova, it will burst into view, possibly shining as brightly as Arcturus or even Vega, some of the brightest stars in our sky. Even in urban areas with moderate light pollution, the nova will likely be visible to the naked eye during its brightest phase, lasting for days or even a couple of weeks. The power of 476 trillion hydrogen bombs. To grasp the magnitude of the explosion, imagine this. The energy released in the nova of T. Coronii Borealis is equivalent to the detonation of 476 trillion hydrogen bombs. This explosion, although taking place thousands of light years away, will still appear as a brilliant new star in our skies. The process involves intense gravitational forces compressing the accreted hydrogen on the white dwarf surface. Once the pressure and heat become unbearable, the hydrogen fuses into helium in a cataclysmic flash. The energy release sends the outer layers of gas hurtling into space, creating the nova's visible glow. At the moment of eruption, the white dwarf will reach temperatures of about 10 million degrees Celsius, hotter than the core of our sun. Science in action. How we know it's coming. This is not a lucky guess. Decades of observation and modern technology have brought us to this point. Since the early 2000s, astronomers have closely monitored T. Coronii Borealis. In 2015 and 2016, fluctuations in its light became more pronounced. By 2018, and especially 2023, these changes closely mimic patterns seen just before the 1946 nova. Today, observatories and satellites are trained on the star system 24/7. Sensitive instruments are measuring every flicker, every rise in X-ray and radio emissions, and every change in the surrounding space. These observations help refine our predictions of when the critical mass will be reached and the nova will occur. When it does, it won't be a surprise. It will be the culmination of meticulous science and a celebration of human curiosity. A glimpse into the distant past. Even though we will witness the nova in 2024, the actual explosion happened 3,000 years ago. The light from T. Coronii Borealis has traveled across the galaxy, reaching Earth only now. To put that in perspective, 3,000 years ago, the Iron Age was beginning, ancient Egypt was thriving, and Greek city-states were just starting to form. So, in essence, we're watching ancient history unfold in real time, a cosmic echo of a moment long gone. What comes next for T. Coronii Borealis? While the upcoming nova is temporary, it's not the end for T. Coronii Borealis. The white dwarf will cool, shrink back to normal brightness, and continue its gravitational theft from its red giant companion. But one day, perhaps thousands or millions of years from now, the white dwarf might accumulate enough mass to exceed the Chandrasekhar limit, about 1.4 times the mass of the Sun. When that happens, the white dwarf will no longer be able to support itself against gravity. It will collapse and explode as a Type Ia supernova, a far more powerful event that would completely destroy the white dwarf and potentially leave behind a neutron star or a black hole. Until then, we may be lucky enough to witness a few more novas from this incredible system. Don't miss it, a once-in-a-lifetime celestial event. The 2024 nova of T. Coronii Borealis may be the only chance in your lifetime to witness such a dramatic celestial explosion with your own eyes. It's a reminder of the incredible forces at work in the universe, and of how small yet connected we are to the stars. Whether you're a seasoned astrophile, a hobbyist with a backyard telescope, or simply someone who enjoys the wonders of the cosmos, this is your moment. So set a reminder. Keep watching the skies. And when the night comes and that new star appears in the arc of the Northern Crown, take a moment to marvel. You're witnessing stellar history, a cosmic heartbeat that echoes through millennia.